Welcome to session 3 of Innovator Island, where we will be building a serverless web application for a theme park. These videos are consecutive, so if you haven't seen the first two, I recommend you go back to the very first one and follow through as we set up the resources that you'll need in this session. My name is James Bezic, and I'm a Principal Developer Advocate here in the AWS Serverless team. Prior to being a DA, I was a product manager and a software developer for a long time. And I built quite a few serverless applications, all using serverless technology and nothing else. So the most important thing on this slide is my Twitter handle and my email address. So if you have any questions about this workshop or anything in serverless in general, feel free to reach out to me and I'll do my very best to help. So today, this is session 3. We are halfway there. In session 1, we set up Cloud9 and the backend, and we deployed a front end with Amplify Console. And in session 2, we integrated the real-time ride times into the front end. So the goal of this entire series is to learn how to use a range of different AWS services to build a real-time web application. All of the code is provided for you, so you won't need to write any actual code to solve the challenges. Now in this session, we've got 3 things we're going to cover. The first is this Chroma and image compositing module. So the front-end app allows users to upload photos. The photos contain a picture of a person against a green screen. We'll build a pipeline of several Lambda functions to process this application. Now, first, chromakey. This is removing the green or blue, or really any color, from a background, and it's a common technique used in movies and TV. The second step is compositing, taking the masked image that's left behind with transparency and then compositing layers of other pre-existing images to create a final image. So in terms of services and architecture, Lambda and S3 are the main tools for today. We're going to be using a library called OpenCV, which is a Python library that we can use for chroma key manipulation. And we'll be using an NPM library called GIMP, which is for compositing. And we're going to show how we can use 2 different runtimes in a single application in serverless. We'll be using Node and Python together. So the most important part of this whole video is the coding part of how we go through what's going on in Module 3. So I'll be stepping through the workshop in real time and coding side by side with you. You can pause the video whenever you need. If I get ahead of you or if you need to take more time in certain steps, I'll be waiting for you when you unpause. There are a few prerequisites for these workshops, so just run through this very quickly. First, you do need an AWS account. If you don't have one, you can sign up at aws.amazon.com. Also, please use one of the supported regions listed in the documentation. It's not available in every single AWS region. The workshop is currently deployed to 6 regions. In terms of cost, running this workshop is absolutely free in terms of listening to me and going through the steps, but the steps themselves might incur small charges. For most people, everything we're showing you should be doable within the free tier. Now it's important once you finish the workshop to go through a cleanup section that you'll find in the documentation to remove all the resources and make sure you don't incur any accidental charges once you've finished learning from this. To take part in the activities in this session, you'll need a laptop or a desktop computer, not a tablet. Also, please use the Chrome or Firefox browser for optimal compatibility. We'll be building the serverless applications with a wide range of services throughout this whole workshop, including Lambda, API Gateway, DynamoDB, just to name a few. Existing familiarity with the AWS Management Console is useful, but it's not required. Everything we're doing continues from previous sessions, so if you haven't caught up with those, I recommend you go back to session 1 and start from there. Remember, our goal here is to help you complete the workshop, so don't hesitate to reach out to me if you have any questions. So this is the day 3 session we're going through, and we want guests to be able to take pictures of themselves on the rides. So in this section, we'll be using a photo processing process. So in this, users upload images of themselves against a green screen using their phones. On the back end, we're going to process these images with Chroma key and then composite an Innovator Island overlay and frame. So how does this work? Well, first, the front end uploads the guest photo into an S3 bucket via an API gateway endpoint where it receives a pre-signed URL. When the object arrives in the upload bucket, it triggers a Lambda function that removes the green background from the photo. When the object is then saved in the processing bucket, that triggers a second Lambda function that composites the image. And when that final image is ready, there is a final Lambda function that updates DynamoDB and then notifies the front end that the photo is ready. When you are finished, you can test this with what you've built. Since we don't have real rides in this room, you can use a green screen if you have one available, or we have a photo with green screen backgrounds that you can use for testing. And you can also share your final photo on Twitter, so use the hashtag InnovatorIsland. So after this section, the front-end application will then have the ride photo processing capability for our park guests. So I'll just talk about the upload process in just a little bit more detail, because when you upload photos and media from mobile apps to S3, it works a little bit differently to the way you might expect. So in the first step, the mobile app, or the web app in this case, will ask an endpoint, an API gateway endpoint, for a pre-signed URL. And it gets that from a Lambda function we're calling photo uploader, which then asks for this upload URL from S3. This request results in a URL that is then used by the client front end to do the upload. So that's important because the client application uploads the media directly to the upload bucket. And so it doesn't actually upload to any sort of proxy like API gateway, or in the case of traditional applications using a server to do the upload. So this is a major benefit of uploading media serverlessly directly to S3. It takes a lot of processing off of the back end of your application. So this is how the events then unfold. So then you upload that image directly to that bucket, which triggers a Lambda function. That put object event then triggers another Lambda function, which then writes to another S3 bucket, which triggers the final Lambda function. So when you look at the green screen image, this is an example of the ones that we'll be using. And so the original image is the person against the green screen background. When that is finished processing with our OpenCV library that we talked about, that creates the same image but with a transparent background. The transparent background is then put into the processing bucket. The compositing bucket takes these, or the compositing Lambda function takes these extra assets which show a park background and an Innovator Island frame, and then those get composited together with the person to give you this final image. So this S3 upload process is really powerful for mobile and web applications when you're handling media or file uploads. And so it's really important because often you find with mobile apps in particular, your upload traffic can be very spiky with lots of users appearing at once. And so having a service like S3 handling that load means you don't have to think about scaling out servers or other resources within your application. There are a couple of steps to doing this, as we'll see a little bit more once we get into the code. The first is to set up an S3 bucket with the correct cores configuration. When you have a front-end application, like a web application, it's really important you have your cores configuration working properly, or you'll start to get cores errors from your code. Also, it's important to set up your Lambda function with a put object IAM policy. And the reason for that is that the Lambda function is making the request to put an object into S3, and so it needs that permission, otherwise you'll get an access denied error. On the front end, you're getting this pre-signed URL from the API gateway endpoint, and then you're uploading directly to that signed URL from the front-end application. The signed URL has an expiration, and usually it's set to 300 seconds or some sort of amount that allows the right amount of time for the front end to complete the upload. And the URL expires after that, and you can no longer use it for uploading after that point. Okay, so that's a bit of an introduction. Let's get started with going through the module. So I'm picking up where we finished off of Module 2. So in Module 2, we set up all the real-time ride information that you see in the application here, and you saw these messages that have been coming in through IoT Core. And now we're moving on to Module 3, which is all about on-ride photo processing. So to get to this, if you have that link s12d.com/island workshop, that will put you at this page. So I'll just go to Island Workshop, and it takes you to the main instructions, and just click on 3, on-ride photo processing. That's everything we'll be doing in this hour. So to start with, we need our Cloud9 instance. So if you still have that running, great. But if not, just go to any of the pages within the AWS Management Console and just go to search for Cloud9 and click on that option, and you should see your theme park environment there. So just click on Open IDE, and that'll take a couple of minutes to start up, but it will take you back to the IDE that we had open in the last session. I'll just clear this down so it's ready for this session. This is our scratch pad from yesterday. If you have that, great. If not, don't worry. And then all the files we've downloaded so far are on the left-hand side here. If you don't have all of this, make sure you go back to the first video and just follow through the steps to deploy all these resources. All of these videos are consecutive. Okay, so let's take a look at the photo processing part of the workshop. So this is going to use the Lambda function to do a chroma key and the compositing process on an image. So the scenario is that in the theme park, we have park guests who want to take photos of themselves against a green background, and we're going to then composite those images. And they can do this all through the web app, where the image will be captured on a phone and then uploaded to an S3 bucket and then processed, and then when it's finished, we'll send a notification to the front end that now the new photo is ready to be viewed. So that's what we're going to be doing here. So there are 3 parts to this whole thing. We've got the first step is creating the chroma key Lambda function. That's the part that removes the green background. The second step is the compositing, where we take those other elements of the frame of Innovator Island, the backdrop of the roller coaster, and we put all those 3 things together. And then the third part is the post-processing to let the front end know that that image is ready. So let's start with the first one. So this is the chroma key function. Now inside this section, the interesting thing about this is that this process involves 2 different runtimes. The first part involves Python and the second involves Node.js. And so in serverless applications, it's possible to combine runtimes even within the same application. So you can really get to choose the best runtime for the task. Also, the OpenCV library, which is the part that does the chroma key process, is a Python library, but it has to be compiled for a target operating system. The binaries involved will depend upon which operating system you're compiling it on. So if you don't have an operating system that works with, that is compatible with Amazon Linux 2, then it won't be easy to deploy that package. So what we've done to simplify deployment is create a layer with OpenCV already available for you, and that's what we're going to be using in the workshop. Now, if you want to learn more about Lambda Layers, because these are a really great way to bundle libraries and other common components you want to share with your applications and your teams, or even with the public, follow the link here. There's plenty of information about how you can then use those layers in your own applications. Okay, so we'll get started here. So we'll follow these step-by-step instructions just like before. On the left will be the instructions that you can see publicly at that link, and on the right will be the steps I'm taking throughout the workshop, so you can see how I'm completing the different steps. So step 1 is go to the Lambda console, and so from the management console, to get there, we're going to go to any one of the management console pages and search for Lambda. And I'll just click that. And that opens up the default Lambda console. And just make sure that you're in the same region that you've been using throughout the workshop. So I'm using US East 1. We support the workshop in 6 regions, but just make sure wherever you are, it's the same place as you've been in previous modules. In step 2, we're going to select Create Function. So we're creating a new function. I'll click that there. And we're giving it the name Theme Park Photos Chroma Key. So I'll just copy this and paste it in. And then we need to make sure that the runtime is Python 3.6, because that's the version of Python the layer is compatible with. So in the list of runtimes, you'll see that Python has a more recent version, but we're going to go and select 3.6 for compatibility. On step 3, open the Change Default Execution Role drop-down, And then use an existing role, select that radio button. And then we want to use this theme park Lambda role that we used in the previous module as well. So I have lots of different roles here. So I'll just type in theme park Lambda role. You should see a role like this in your account with a different code at the end. Okay, so then what we've set up here looks just like this image. And so now I will select create function. Okay, so that's now been created. You'll see a success message when you do the same. So in step 4, right now this function doesn't do anything in particular. It's just got a basic handler. What we're going to do is set this up so that it's going to be invoked by an S3 bucket when the image is first uploaded. So what we're going to do is click on this add trigger button on the left here. So in the trigger configuration drop-down, select S3. So you'll see a list of all the services. You can scroll down to S3 or just type to match. So I'll type there. And that gives you all of the different parameters that you need for integrating with an S3 bucket. Now in the bucket drop-down, we want to select the bucket that contains the upload bucket keyword there. So you'll see there have been a number of different buckets that have been deployed as part of this workshop, but it's the upload bucket that we're interested in right now. For event type, the default is all object create events, so just leave that as default. And then as before, you've got a recursive invocation warning just here. You just have to accept that acknowledgement. What this is basically if you have an S3 bucket invoking a Lambda function and then you write contents back to that bucket, you can cause a recursive loop. So we're just making you aware that's something you should avoid doing. And you'll see that my settings here are the same as this now on the left-hand side. So I'll click on add. Okay, so you'll see a message at the top saying that the trigger was created successfully. And now the function is receiving events from that trigger. So right now, if we uploaded anything to that bucket, it would invoke this Lambda function, and you would see that in the logs. But the function doesn't do anything just yet, so we'll keep going. So moving on to step 5. Back on the Lambda function page, you want to select the code tab. We're currently on the configuration tab, so I'll select this code tab. And then we'll scroll down to the layers card. There's lots of information here, including the code we have for this function. And here is the layers card just here. So now we're going to add a layer. So I'll click on the add a layer button. Now for each region that the workshop is supported in, we've set up a layer containing the OpenCV library. So you want to match the region you're currently in with the region in this table. So I'm in US East 1, you might be in a different region. So just make sure you pick the region code there and match it with the list of regions on the left hand side. So US East 1, I'm selecting this ARN just here, and I'll copy that to my clipboard. Now we will then have to click on the specify an ARN button. That's an Amazon resource name, and then we'll paste in that ARN from the table just here. So that's step 7, paste in the ARN and then select add. And it's as easy as that to add a layer to a Lambda function. You can also do it through the CLI and through SAM templates as well. So it's a very easy way to bring in libraries and other common resources that you want to use in your functions. Now this function I already packaged up just for simplicity in the workshop, but if you're interested in seeing what's in it, you can follow that link and see what's in the zip file comprising of that OpenCV library. Great, so we're now on step 8 and we're back in this Lambda function page. Now let's make sure the code tab is selected, and then we want to view the code source card, which is this one just here. So again, you'll see this default code that's provided because it's a brand new function. This is an empty Lambda handler, and all it will do is return a 200 status code with this message hello from Lambda. That's not what we want to use, so we're going to replace that code now. So step 9 is to copy the code from the file in Cloud9. So let's go back to our Cloud9 tab. I still have it open. And we're going to this directory, 3 photos, 1 chromakey, app.py. So let's go to the backend. I'll close that one. Go to 3 photos, 1 chromakey, app.py. So this is the code that we want to use for our Lambda function. So we're going to copy this onto a clipboard and then go back to the Lambda function, select all of this and remove that, and then paste in that code. Now once you've got the code there, you'll see the changes are not yet deployed, so in step 10, let's deploy that code. Now what this does is, this is using OpenCV to perform this chromakey process. And the code is actually fairly straightforward. You don't need to, because the library really does all the work. And so what this is really doing is it's fetching the bucket name and key from the event that's passed in, and it's taking a couple of environment variables that act as parameters for HSV values, which is enable us to work out the shades of green in the background that we want to remove. So this code is dependent on a few environment variables that we've not configured just yet. But we're doing that next. So we've deployed those changes. You see the message changes deployed. That's step 10. And the next task is to add these environment variables. So we have 3 environment variables that are important. There's the output bucket name. This is the place that the image is going to be placed where after the green background has been removed. Then these 2 upper and lower bounds for HSV values. Now I've picked default values that work with a broad range of different green screens, but if you find that the green screen compositing isn't quite working for you, you can change these values and play around with that process. So let's look at how we can change these environment variables. So in the step 1, we're going back to the Cloud9 IDE. Now we want to find out the name of the output bucket for this function. So we want to look at the processing bucket. And it uses this command ls, which just gives us a list of all of the S3 buckets in our account. And then we're just using grep to pull out the processing bucket. So I'll paste that into the terminal. And you can see it gives us a timestamp, but also that's the information we really want just there. That's the bucket name. So if we go back to the browser tab, we now want to put in these environment variables. I've copied that bucket name. I'll go back to this Lambda function here. So let's now add those environment variables. And the way you do that is you go to the configuration tab, it says here, and then choose the environment variables menu from the menu on the left. So just select that. And then we'll choose edit. Now we want to add 3 environment variables, so I'm going to click this 3 times, and I'll paste in the bucket value so it's there, and now I'm going to copy in the key, which is output bucket name. So that's now referencing this value that we got from Cloud9 just down here. The other 2 values are fixed, so all we have to do is put them in place, and so we've got an HSV lower, and each one of these takes a tuple, which can then be used in that Python function. So when I've finished, you'll see this looks like the screenshot that we have. Now you'll notice I've put the output bucket name first instead of last. The order doesn't actually matter, so you can choose any order of keys that you prefer. Once you've made these changes, don't forget to click Save. So that's important, so we'll just choose the Save button there. And once those have been saved, you'll see now those 3 values appearing in this environment variables card. So let's scroll down to the next step. So what we're going to do here is, when we created the Lambda function originally, it only has 128 megabytes of RAM and 3 seconds of timeout. So that's fine for a lot of basic Lambda functions. If you're just moving JSON around or something simple, those settings are absolutely fine. But for memory-intensive applications, such as ones that process images, 128 megabytes is not enough. So you have to change those settings. So the way we do that is if we go back to step 1, in the browser tab with the chromakey Lambda function, and we're actually already there, so you see this is our Lambda function. We're going to open the configuration tab, and then choose the general configuration option just at the top there. And there you can see the default settings. So in step 2, I choose Edit. Now I'm going to change this default setting to 3 gigabytes of RAM, thereabouts, 3008 megabytes. Then I'll change the timeout value to 10 seconds. The timeout value is really a safety guard. So if you have a function that just never returns or it continues on forever, the timeout it causes the Lambda service to stop the function. So you don't want to set it too close to the amount of time that you expect. You want to allow a few seconds after. But if this function were to run for 10 seconds, the Lambda service would then terminate the function. So these settings again match this image here. So now we want to go to step 3 where we select Save to update the function. Now you can define up to 10 gigabytes of RAM per Lambda function, so you have a lot of scope for changing the amount of memory, and when you change memory that also changes the amount of virtual CPU available to the function, which is really important to remember when you have compute intensive functions. So the next step is to test this function. So we set up this S3 trigger, we've imported the OpenCV layer, and we've set up the code needed for that to run, and we've changed the memory and the timeout. So let's see how this works. So in step 1, we go back to the Cloud9 IDE, and we're going to navigate to this file just here. This is theme park backend, the photos folder, and inside there you'll see a green screen test PNG. If we look at that, that is an image of a person, that's me, against a green screen. So that's what we're going to be using in our test. So moving on to step 3, we're going to enter this command to change directory into the photos folder, just to make sure we're in the right place. I'll clear that. And then this, we use the same command to find out the name of the upload bucket. So it's this name here. And then in step 5, we're going to copy that image up to that bucket using the CLI. So this command here gives you this placeholder name that you need to put in the upload bucket name in. So I'll copy everything up to that point. And then I'm just going to take this name here, copy that, and paste it on the end. So now this command will copy that test PNG up to our S3 bucket. So that's now been uploaded. Now if I go to step 6, in another browser tab, we're going to go to S3. So I'll go to this tab, and I'll look for S3 in the service dropdown, and I'll open this in a new tab. So that opens all of our buckets that we have available. Now I've got quite a few buckets in this account, so I'll filter on theme parks, so just show the buckets for this workshop. And in step 7, we're interested in the bucket that begins with theme park backend processing bucket, which is this one just here. So what you'll see here is this file called greenscreentest.png. It's the same file name, but this is the result of the chromakey function. So this is the output from that function. So on step 8, we're going to check this box here, and then we're going to go to the actions drop down and choose download. So I'll just choose download there. And in step 9, we're going to open this file locally and see what it looks like. And now you'll see this doesn't contain any of the green background that we saw in the original image. So this has been successfully processed. So that now is the first part of this challenge solved. So anytime images arrive in the upload bucket, that will invoke that Lambda function that will remove the green background and put the results into this processing bucket. Okay, so now we'll move on to the next steps, which is to create the compositing Lambda function. So this function is going to be triggered by the image arriving in this processing bucket. So really we're chaining together Lambda functions and S3 buckets to cause this to happen. So we built that Lambda function manually in the console the last time, but in this case, we're going to use SAM, the serverless application model, to automate the deployment of this second function. Now, SAM is actually just a template made of YAML, so nothing too complicated. And we're going to use that template to declare what we want to build in AWS. So this is a really good way to deploy your applications because it makes your deployments repeatable. You don't have to go through the console and click things where you might make mistakes. And we're going to do this all in Cloud9. So in step one, we go back to our Cloud9 tab. I've got this running here. I'll just close this down, clear down the terminal. This is my scratch pad for any details we want to keep as we follow through the steps. And in the Cloud9 File Explorer in step 2, we're navigating to open the template that's in this directory, theme park backend, 3 photos, 2 compositing. So backend, photos, compositing, and that's that file just there. So let's take a quick look and review the contents of this file. So SAM templates always begin with the same 3 lines at the top. This is an instruction that it needs to be converted into CloudFormation. So SAM does this when you deploy this template. We have a description here that you'll see in CloudFormation when the stack is deployed. It's just helpful for us to refer to as what the stack actually does. And then these templates contain these sections. So you've got a parameters section where we're going to take a bucket name, which is a string. There's a global section that we can take attributes that apply to multiple functions. This only has one function, but gives you an idea of how that would work. This is actually the same as putting the timeout directly into the properties list. And then there is a resources section where we define all the different resources that we want to use in the template. And this could be API gateway endpoints, it could be DynamoDB tables or Lambda functions, and many, many other resources. This template just has one function, so it's pretty straightforward. And it defines that this is a runtime that will be Node.js 12 using 2048 megabytes of RAM. And the environment variable is passed in just here. So it's going to take that parameter that we enter when we deploy the template and pass it in just here as a reference. So SAM, when we deploy this, is going to then read all this YAML and turn it into infrastructure. So we just reviewed some of those points there. And the only thing I've not shown you here is that in this properties section, in this Lambda function attribute, this defines where the code will be found for the function. And in fact, that's contained just here. Now, if I open this is the Lambda function that's going to be deployed. You can see that this is a Lambda handler just here. And what it's going to be doing is pulling in or loading a few different attributes or a few different assets for a compositing process using a library called GIMP. GIMP is an NPM library. So using this few lines of code, it's going to composite those few graphics elements, and then this part here will output this to S3, to an output bucket. And so that is the whole Lambda function contained there. Okay, so let's look at how we're going to deploy this code. So I'll close this down. First of all, we're going to change directory into that compositing directory in step 1. Now it uses this final bucket environment variable, and so we can look at what the value of that is using this ls command that we've used a couple of times now. But we're actually now grepping for this final bucket, and so that's the final bucket. You'll find your code is slightly different because these are unique per deployment. Now in the terminal, we're going to execute the following SAM CLI commands, and they do 3 things. So first of all, we're going to build. SAM build runs the package.json file that's here. And this contains these 2 libraries, the SDK for AWS and also the GIMP library that we're using for compositing. And then once we've run SAM build, then we'll run SAM package. SAM package takes those resources, bundles them up, and will deploy them to the S3 deploy bucket that we set up earlier. So it uploads the entire package to that S3 bucket. And then SAM deploy will take all of that and actually deploy the assets using CloudFormation. So this takes a couple of minutes, and it's going to deploy the Lambda function, the IAM role, and anything else that we've specified within that template. So what we'll do is we'll just wait a couple of minutes here for this to deploy before we then go on to check what's been deployed. Okay, so that's now been deployed successfully. So you'll get the same success message when in your deployment. So before we move on, I'll show you that in our Lambda console. So if we go back to Lambda, I'll just go back to the list of functions. And if I just sort by the most recent, 31 seconds ago, that was just now, that was the function that was deployed. And so if I show you this, you'll see that this is just like a regular Lambda function created in the console, but we did it programmatically. So here we cannot see the code source because the package is too large to be able to manipulate in the console, but we can still change any of the metadata that we want to if we want to go into configuration and change things here if we wanted to. But you see this is already set up with 2 GB of RAM as we defined in the template and with a 10-second timeout. Okay, so going back to the instructions, we go to the Lambda console, which if you're not there, just go to any AWS page and search for Lambda this way. And you want to make sure that your region is the same region that we've been using throughout the whole process. So select that composite function, Lambda function, which is just there for me. Now right now this function is not being invoked by anything. So what we're going to do is just set up an S3 trigger. So I'll go to add trigger and then I'll define S3. And in here we want to then, in the bucket dropdown, select this processing bucket. So that is that one there. Now we want to make sure that we leave this as the default, so all objects create events. And then we check our recursive invocation warning again, leave the other entries just blank, and then click on add. That function now is going to be invoked by our processing function. I'll just refresh that. Okay. So now we've chained together 2 buckets with 2 functions. So from the first upload, that'll cause the Chroma process to happen. That puts the output in this processing bucket, which will invoke this Lambda function, and that will put the result in this final bucket. So the way we can test this, we'll go back to the step-by-step instructions. We're going back to Cloud 9. I'll clear this so we can see what we're doing. And in the terminal, we're going to change directory into the photos directory. We'll look up the name of that upload bucket again using that same command. So that's the name of the bucket. Now you remember we set up this upload bucket variable. So just to show I can echo this, this has already been configured. So we can use this in the CLI command when we copy up that green screen test image. We don't need to cut and paste as we were doing this earlier because we already have this variable. So pasting that in there, that uploads that green screen test image. So in step 5, we're going to go to the S3 console. I'm going to just filter for theme park buckets since I have many, many buckets here. And we're looking for the one called final bucket. That's this one at the top. And in here, you'll see there's now a green screen test.jpg file. And this is a result of the test. You'll see the timestamp is the same as now. So what we can do, if we then download this, we'll check the checkbox in step 7, and then choose download. And we'll open that file. And what you'll see is we've got this composited final image with the Innovator Island frame and the roller coaster background with the person in the middle. So we've taken all of those image elements and put them together. So the next step now is to handle the post-processing of this. So right now you could upload this from the front end, but the front end then doesn't know once the process has been completed. So we need to find a way of alerting the front end. So that's the final step. So in this section, what we're going to do is we're going to put the entry into DynamoDB to keep track of these files as they come in. And then we're also going to use IoT Core to let the front end know that a new photo has been processed. So in this section, we're going to build a Lambda function that completes this final step. And then we're going to test from the application itself. So first of all, step one is we're going to go to the Lambda console. So I already have this open. If you don't, just search for it in the heading at the top there. And that'll open up the Lambda console with all the functions that we have. I'll just filter for the theme park functions since I have many, many functions in there. Now you want to just make sure your region is the same. We've done this a few times, but it's easy to accidentally switch that. So just double check and then click on Create Function. I'm going to enter theme park photos post-process, and then we'll make sure we're using Node.js 14. That's pre-selected right now. And in step 3, I'll open the Change Default Execution Role dropdown, select the Use an Existing Role radio button, and I'm going to look in the dropdown for one that contains the phrase theme park lambda role. So I'll just start typing to match that. I see that's the role there. Yours will be the same except with a different code at the end. We select this role and we can see that our screenshot there looks very similar to this here, and then click on Create Function. Once the function is created, you'll see a success message at the top. So this theme park post-process Lambda function isn't currently being invoked by anything, so we want to change that now in step 3. So in step 3, we will add a trigger and select S3 as the trigger from the list. In the bucket dropdown, I'm going to click the dropdown and look for this final bucket just here. You'll see that if you just search for that phrase, you'll find the same thing but with a different code on the end just there. Again, we're going to let all object create events here, and we're not going to use any of the prefixes and suffixes. You could use this to restrict certain types of files causing the events to be invoked. So for example, if you just wanted JPEG files to invoke a Lambda function, you could specify that there. Again, we'll just select this recursive acknowledgement and then click on Add. Okay, so now we have a success message that the trigger has been created successfully. And so this is now receiving events when objects are being created in that bucket. Obviously, right now the function doesn't do very much. So what we're going to do next, if we just scroll down, we completed that. In the Lambda function page in step 4, we're going to select the Code tab. Now we're going to copy the code from the post-process app.js from Cloud9 onto the clipboard. So we go back to Cloud9 just here. I'm going to go to 3 post-process. Let's open up that folder app.js. And this is the code that we want to use. So I'll just copy all of this. I'm going to go back here and I want to replace all of the code that's in there already with this new Lambda function. So once you've done that, you've pasted in the contents from the app.js file from Cloud9. Don't forget to then click deploy in step 7. It shows it's not currently deployed. So we'll click on deploy, and that then commits that new code change. So what does this code actually do? Well, this does 2 things. It writes to DynamoDB. I'll just switch to the Cloud9 instance so you might be able to see the code more easily. Here's the handler. So it writes to DynamoDB and it publishes to IoT Core. And in the saving to DynamoDB, it uses this document client tool to write the item to DynamoDB using this environment variable. And then the IoT publish function there calls the IoT data publish SDK to pass along the message as a payload to the IoT topic that we use. So really, these are just one-liners that you can use to make these changes. It's pretty powerful. Okay, so let's go to the next part to add environment variables that this function needs to be able to make this code work. So there are two variables. We've got IoT data endpoint and the DynamoDB table name. So in step one, we're going to go back to Cloud9, and we need to then, in the terminal, enter this command to retrieve the IoT data endpoint. We already deployed this stack in module 1, so we're just fetching the endpoint address that's already been deployed. And then next we're going to use this command to get our DynamoDB table name there too. So we've got both those two values that we need to better copy across. So in step 4, I go back to the browser tab with the theme park post-process Lambda function open, and then select the configuration tab just here. Now the next step is to then click on the environment variables option on the left. And you'll see there's nothing set up so far, so we'll then choose edit to add these in. So in step 5, I'll then click this button twice so we can create two environment variables. And we want to copy across the DynamoDB table name. I copied that just here. Paste that in. And then the IoT data endpoint. So I'll copy that, paste that there. And I'll copy that endpoint there and paste that in. So when you're done, you should have a screen that looks very similar to this, where you've got the two keys, doesn't matter which way around they are, with the DynamoDB table and the IoT data endpoint. And then the step 6 says choose save. And once that's been successfully saved, you'll see those two environment variables. Okay, so the next step is to update the front end. So what we need to do there is go back to Cloud9 in step 1. I'll just close this down and I'll clear this terminal. And we're going to run this first command, which is going to give us an API endpoint that's used by the front end to request pre-signed URLs to upload images to. So this is a function that actually we've already deployed. So that URL there, I'll put this in my scratch pad, my upload endpoint. And so you want to copy that to the clipboard in step 3. And then in step 4, we'll then navigate to the front end code, which is down here in the front end directory. And we're looking at this directory src and then locating the config.js file. So this is module 3, and right now the photo upload attribute is blank. So what we need to do is just take that upload endpoint that we copied and just paste that in here. Then we'll save this config.js file. Remember, in Cloud9, if it's got a little ball icon appearing on the file has not yet been saved. So we'll make that change and then save using Control S. That ball now disappears. And now we've made this change. And we can check that change by doing git status. Actually, we have to change to the front end directory first, so I'm in the right repo, so do git status, and you'll see there is one file to be committed. So we'll commit that file now using git commit, and we'll say module 3, and then git push using this command here. And that's pretty quick because it's a tiny change. And now once again we're going to go to Amplify Console, which will automatically have detected that it needs to build the application again because there's been a change to the Git repo. So I've got this open already in a tab. If I didn't have that, I could just click this link, or I could reach this from another service. So if I click in Amplify, I can open it this way as well. I'll just click that tab. You'll see there. Now this is running because it detected that change in the GitHub repo. So we saw this last time, but let's just review this. In this build process, Amplify is going to provision an environment and then start building the application. And what that means is it's realized this is a Vue.js application, so it's going to download that, run npm install to install all the packages it finds in the package.json file, and then get a dist folder, which is what you have in Vue.js, for the public output. And then in the background, it's going to copy all these files over to S3 and set up a CloudFront distribution and do lots of things we could do manually, but we can automate it entirely with Amplify console. As before, the public URL of the application will not change. It's simply going to deploy the new version and then point this URL at that new version. So Amplify console really does automate a lot of the steps for us. This will just take a couple of minutes to complete, and we'll wait for this to complete before we continue any further. Now, while that's building, the public URL for our application, which we have open over here, this has been open the whole time. This is still running the old version, and so it's still receiving those ride times at the moment. Okay, so that build is now complete. It's now deployed those changes, and what it's doing is it's just verifying the deployment to make sure that it looks good. This is a final step that the Amplify console does for you before it points over the public URL, and it takes just a couple of minutes. Okay, so that's now finished. So if I go back to the same deployment URL, I'm going to do a hard refresh. Let's Control F5 on a PC. And that's now the new version of the front end. And what we can do, if we go to step 5, which is opening that URL, the big change here is if we open one of the rides, you'll now see there's a button that says Add Ride Photo. So this enables us to add ride pictures. Now, if you went to this URL using your phone, you can actually upload a green screen image if you have a green screen available. But if you're just using a desktop, you can use the image from the repo to do the upload. So I'm going to do that. I'm going to just use, I'll just go to ctemp, and I have a green screen image here that I'm going to upload to simulate if I was on a phone. So this is interesting, and what happened here is that you'll see in the console, this is all the binary data that was uploaded, and now we've got this alert coming back saying the photo was processed. So what just happened here? Let's just step through this. Well, we can look at the final image in the gallery, and that's the composited image. So when that image was first uploaded, it fetched an upload URL from that endpoint that enables the front end to upload the green screen image directly to S3 without using any type of proxy in the middle. And so that's what this upload was. It uploads a blob directly to S3. That then started this whole chain of events where it triggered the chroma Lambda and then the compositing Lambda function before triggering that post-process function, which then alerts but sends a message to IoT core that the image is now available. And that's the message that came back, this photo processed alert showing that that was ready. So although that took a few seconds, what happened was we had a completely asynchronous process here where the front end did the upload of the image and then the back end processing was handled asynchronously, and we used IoT core to push the alert back to the front end that the image was now ready to be viewed. So that is the entire module. We've now tested the feature, and so in a virtual workshop, use that green screen test image to then test these. If you have a green screen available to you, you can reach the URL on your phone and line yourself up on a green screen and take a picture. If you do that, please share it on social media with us. We'd love to see how your images turned out. So that concludes module 3 of session 3 of these videos. And if you have any questions at all, please reach out to me on Twitter or on LinkedIn using the contact details at the beginning of this video. If you're going to move on to module 4 straight away, please don't close any of your tabs. I'll pick up directly where we left off. If you need to close, no problem. I can show you how to open Cloud9 when we get to module 4. Thanks very much for joining me for this hour, and I'll see you on the next time.